Hey everybody, I'm Chili. Welcome back to Beginner C++ Tutorial 12. Now today I'm going to take you on the first steps transitioning from a code tinkerer and dabbler to a master code architect. What I'm talking about here is the ideas of encapsulation and data hiding.
Y'all need to hide your kids, hide your wife, and hide your husband because they raping everybody out here.
Now, as far as actual C++ topics go, we're going to learn how to create our own constructors, how to initialize member data, and how to control member access in a class. Alright, so now that we've learned about references, which enable us to create things like draw functions for our poo and our dude, we can now do the thing that I originally wanted to do, which was make all the data members private. So, first of all, what does it mean? What does it mean to make data members private? What's the difference between public and private? Well, here you've got a little diagram and it shows you've got a class, right? And the class has private stuff and it has public stuff. Now, the public stuff is accessible from the outside world, from objects, from other classes basically, and they can access the data and the functions that have been marked as public, but they can't access any of the stuff marked as private. It's not possible. But inside of the class here, the functions inside the class can access anything else inside the class that they want. So inside the class, anything can access anything else, but outside, you can only access the stuff marked as public. Now this diagram is kind of shitty. Don't blame me, I just stole it off of Google image search. It shows some kind of external agent here accessing the public data, but in general, we're not going to make our data public. We do it sometimes, but not usually. So I don't know why this part's black, but whatever. Forget about that. Usually what's going to happen is something like this. So you've got some external agent accessing public functions, and those public functions access the private data and sometimes other private functions. So this is the way forward for encapsulation. You see, in encapsulation, we only want to expose the minimum necessary interface functions to the outside, hiding as much detail as possible here under the surface. And if you're wondering what's the motivation for doing such a thing, and you should wonder, I'm going to explain the reasoning behind data hiding at the end of this video, so don't you worry. Alright, let's get to the code, shall we? I got the poo game code here from the end of tutorial 11 homework, so you can bring that up, and if you don't got it, you can get it on the wiki as usual. Let's go to poo.h and check it out. Alright, so here we got our member functions, we got our member data, and we want to make all the member data private. So we just go in here, we type private, and we type a colon. And that's all you gotta do. Now it's all private here. Now, this is not going to be without consequences. So if we go into let's go to game.cpp. This is the place primarily where our poo is being used. We're going to see a lot of red. So let's go down here. Let's handle what is easiest to handle first. So here we are doing a lot of checks to see whether a particular poo has been eaten or not. And we're trying to access the private data member, which is not allowed. So how do we solve this problem? Generally, the way you would solve a problem like this is, okay, we need access to this member. So what are we going to do? Are we just going to make it public? Fuck no. All we need to do is to be able to read this guy. So let's make a function. We'll call it bool is eaten. And const, because this function is not going to change the state of the object, it's just going to read some value out. And then we're going to go and create the definition, and we're just going to return is eaten. And there you go. Very simple. If we go now back to game.cpp, we see that, obviously we've got to rename all this bullshit. So we'll do some standard find and replace like this, and everyone is happy. And this is a very standard thing to do. We call a function like this, we call it a getter. and it just gets a member variable. Now there's another kind of member function called a setter, and what that does, I mean, you can probably guess, it sets the value of a member variable. So getter and setters are commonly used, but I would say try to avoid them when you can. Like, oftentimes what you see people doing is they'll create a class and they'll make all the member variables private, and then they'll make a get X and a get Y and a set X and a set Y, and do that for every single member variable. But if you're doing that, you're not really hiding the implementation very well, are you? Because you're just replacing direct member access with get and set methods. It's not optimal is what it isn't. So don't just automatically make getters and setters for everything. Look at your problem and say, okay, what information needs to be exposed to the outside, and only make methods for that. I usually don't think too hard about making a getter method. It's not that bad. But making a direct set method, you should probably consider that a little more deeply. You should be more reluctant to make a setter, because that allows an external agent to just tinker around and fuck with the internals of a class, whereas a getter is read-only, can only get information, but it can't fuck things up. But if you don't need to expose either, then don't expose them. Look at our poo class here. We've got X and Y and VX and VY, and I'm not going to expose any of that shit. Why? Because the only things that need to know about X and Y and VX and VY are, for example, draw needs to know X and Y, and update needs access to X, Y, and VX, VY. But those are all internal to poo. Someone outside of poo doesn't need to know fuck. All they need to be able to do is to call these interface functions. They don't need access to this. They do, however, need access to isEaten, because this will determine things like if the game is over or not, and if we should actually draw them or not. I'm not saying, avoid getters and setters at all costs. What I'm saying here is, think before making a getter, and think a little harder before making a setter. That's all. Now, you might ask, well, Chili, in the case of, let's say we have a data member and we're making a getter and a setter for the data member, what's the advantage of even making it private then? Why don't we just make it public? Since you can read the variable and you can write to the variable freely, there's no difference than just making it public. But there is a difference between getter and setter and making a variable public. And let me show you an example. Let's say we've got a class. It's a rectangle. It stores the position, the point of the top left corner, and the width and the height of the rectangle. Now let's say we've got some classes, some functions, and what they're doing here is they are directly accessing the width for some reason. Doesn't matter why, but it's getting the width. Getting or setting the width doesn't fucking matter. All right? And that's fine. But now let's say through development, we decide we don't want to store this rectangle as a point and dimensions. We want to store it as 2 points. So now there's no more width member, and these guys, everything that has referenced that is all broken and has to be fixed. All right? But imagine the situation where we were using getters and setters. So we have a function getWidth, and before it was just returning the width directly. And after we set this, all we have to do is, return x1 minus x0 or some bullshit like that. So if we use getter and setters, everyone using the function or everyone using the class doesn't have to change. All you have to do is when you change the internal implementation, just change the interface function a little bit. Whereas if you were directly linking your external objects to the internals of your rectangle, you would break all your shit whenever you tried to change the internal implementation. So that's why getters and setters have some advantages over publicly exposing internal member data. There are other advantages to getters and setters, but we won't get into that right now. So, good. We've done this. We've created our isEaten, but there is still a problem, big problem here, because we're trying to access the internals of poo in the game constructor, but we're not allowed to do that. We're not allowed to directly set any of these motherfuckers. So we've got a couple of ways we can proceed with this. And one of them would be to create setters for all of these things, and then we could just set them all. That's one way of handling it, but it's not great because, like I said before, it now exposes all those internal things to the outside world in a way that, isn't suboptimal. But how else are we going to initialize the values for our poos? Well, let's look at some other things that we have created along the way, like when we create our uniform int distribution. We call the constructor here and we pass it some values to initialize this object. So can we not do the same for our poo? Can we not create a constructor that takes in the x and y, vx and vy values and then initializes itself? Just as we were able to have the poo draw itself and update itself, can we not have it initialize itself? And we can. We will create a constructor for our poo. So let's do that. Create a constructor. The name, it's a function, and its name is fixed. It has to have the same name as the class. So you name it poo. And here is where you're going to put in the parameters that will be passed in from the outside to help initialize your object. So we want x, and we want y, and we want vx and vy. And I think that is about it. Everything else is set down here. So, great. Then we've got a function body here like any other function, and we can, in this function body, we will write the code that will initialize our object. And that'll look something like this. Only, do you realize something dumb here? Well, we're writing x equals x. That seems a little strange, doesn't it? Well, I mean, the parameter that we're passing in is x, and the member variable that we're using here is x. So when we say x, which x does the compiler take to mean the one that we mean? Which one does it understand? And the answer is, well, these x's are local variables, these x and y and whatever are member variables, so the compiler will give preference to the local variables. So here, we're basically just assigning this local x parameter to itself, doing effectively nothing. This is a terrible idea. And I don't recommend, I do it a lot myself, but it's not a good idea. I don't recommend giving your parameters the same names as the member variables that they're going to be initializing. So what we're going to do is we're just going to go in x, in y, so on and so forth, and that will distinguish these input parameters from the member variables. And there you go. You've got your poo constructor all made up. What's the next step? Well, here is the rub. And the problem is, where do we call this constructor? So here we are creating a local object and we pass in the constructor parameters like this. But the poos, they're not local objects. They are, they're members of game. They are what we call this embedding. And these objects are embedded inside of the game object right here. And you can say, well, Chili, can't I do something like this? Just pass in some constructor parameters like this. And the answer is no. No, you cannot. Look at this. Obviously, the compiler does not like you. So, what's a guy to do? Well, the answer, the clue, is here. We've got an embedded object here, which is graphics. And graphics has a constructor. So, where do we put in the parameters for the graphics constructor? We put them in like this. So, after the constructor function here, you've got a little special thing you can do. You can only do this for constructors, and this is called the class initializer list. This is where you initialize all of the members of the class if you want to. And here is where you pass the constructor parameters to all of your embedded objects. So here we can do something like, we'll just put a colon down here, and we're going to add poo 0. And now we can, here, look, we got our parameters. So we can pass in, let's just pass in some dumb parameters, 100, 100, 1, 1. And look, it's all good. Our poo is now being initialized here. The constructor is being called like this. And that's great and all, only there's one little problem, and that is that we don't want to construct it with just some fixed values. We want to construct it using our random number generator and our distribution. And that is a little bit of a problem because our distribution hasn't been created yet. Our distribution is local to this. And furthermore, our random number generator, it hasn't been created either. So none of these things have been created. And because the initializer list initialization happens before the body of the constructor. And all these local member variables here, they aren't accessible from here. So we can't do this unless, and here's where it gets interesting. So we'll copy this code here, toggle, and I'm going to paste all my random number generation shit in here. Do I have random? I don't have random in the header file, so I should probably put this in here to be safe. And now what I want to do is we're going to get rid of, because we can't call constructors like this, so we're going to get rid of this, and I'm going to remember that that's 770 and 570. Remind me if I forget. So now we have these guys are also members, and so now we can call them from here, but we want to initialize them first. So we're going to go RNG, and we're going to type RD. So that'll initialize the RNG with the random device. And then we want to go XDist, and that was 0 and 770. And the Y distribution was 0 and 570. And now we can copy this motherfucker, put her in here. We can copy the Y distribution, put her in here. And these guys, we just set them to fixed values, so we can do that the same way, just 1 and 1. And we forgot the comma at the end of this one here. And we put a comma here, and we're going to do the same for poo1 and poo2. And when we're done, it should look something like this. And the underline that was here, that was complaining, has now been fixed. Everything's good. We don't need this shit anymore. So fuck off. See you losers later. And now look, all the red has disappeared from our function. If we build, probably no errors, but I'm not guaranteeing anything. All right, beautiful. And everything works fine now. So goddamn good. Now there's one thing that I have to tell you, and this is really fucking important, so you better listen up, because this will fuck you over. Even though I'm telling you this, I guarantee this is going to fuck you over sometime if you continue programming with C++. But listen anyways. Okay, so the initializer list here, what you might imagine happens, like the order of initialization, is you just initialize going down the list here. So first RNG, then the distributions, then the poos. And that is what's happening, but it has nothing to do with the order of items in this list. The initialization of member data in a constructor is determined, the order is determined by the order in which the data members are declared. It has nothing to do with the order of the the class initializer list, and has everything to do with this order here. So if you fuck up and you put the initialization of your random stuff after the poos, shit is not going to work very well. Let's take a look. All right, let's keep calm and eat the poo-poo. Oh, too bad, die in a fire. So, obviously, no good. And the reason why is because we didn't initialize our distributions, and thus, we're getting really weird values initialized into poo. So, regardless, this order here means shit. It doesn't mean anything. It's all about the order inside of the class definition here. So you got to make sure, if, for example, in the initializer, if some of these values depend on other values in the class being initialized, you got to get that order fucking sorted out in here, or it's going to be bad time. It's going to be bad news bears. So, first off, if at all possible, avoid doing what I've just done here, which is initializing with values that are initialized earlier in a class. If you can avoid it, great. Don't do it. You're asking for some butt hurt. But if you can't, or you don't want to avoid it, then make sure you've got your fucking order straight, or you're going to get fucked. Good. I just want to make sure because this fucking happens all the fucking time. It's happened to me many times in the past, and it will probably happen again in the future at some time. Because, you know, you move things around, you delete shit in here, and you forget you're working in this code. You look at this, you say, oh, the order looks good, but you forget that the fucking order is different here, and this is the one that matters. So, that's why I'm taking the time to say this, because it's a major cause of rectal bleeding in C++ programmers. I'm just saying. Now, one last thing here. You may have noticed that I put the implementation for the constructor inside of the class. And you might think, oh, that's how you do it for constructors. But no, you can do this for any member function. I just forgot because I often do it this way because I'm a lazy bastard. But to be consistent, we should actually put this implementation in the CPP file with all the other implementations. And there's a neat thing in Visual Studio that you can do. You go quick actions and move definition location, and there you go. It's just moved that code into the CPP file for us. Fucking sweet. So yeah, it's possible to put function definitions inside of the header file. But for now, let's just, be consistent and put all the definitions in the CPP file. And there we are. Now we've got a class built with proper encapsulation, proper chuffed. And, all of the externally accessible interface things are marked as public. These are like the levers and the knobs and the gauges that the external world will be able to interact with. And all of the internal stuff, the guts, is all nicely made private here. Now, people say this is good. This is a good arrangement. It's a good thing to do. But why? Why is it good to set our code up like this? Let me give you some good, reasons, motivations, incentives for why we do this shit, why we buy into the paradigm of encapsulation. So, one of the reasons is improved code maintainability. Now, this is a big one because projects often fail because they get too big and they get too fucking messed up and there's too many bugs and you can't fix the bugs, and every time you try to fix one bug you create two more bugs and it just fucking collapses under its own weight. And encapsulation will help you to create a system that can be added to and that's nice and modular and modifiable. I mean, if you just got like some fucking tangled mass of yarn bullshit, everything is wired up to everything else. All objects are accessing all the data of all the other objects. Then anytime you change one thing, a whole bunch of other shit is going to break. And then you try to change those things and other shit breaks. And it's just a domino effect of bullshit. So you want to disconnect as much as possible objects from the guts of other objects, and you want them to talk through pretty regular channels that you can control and that are fairly stable. And those channels are your interface functions. And then when you change some of the guts, you don't break a whole bunch of shit. If you change a bunch of the guts, you might break an interface function or two, and then you fix those functions and everything works again. So let me illustrate this with my favorite analogy, and that's the car engine analogy, all right? So you want to control a car engine, you want to control, how much power it outputs, how fast, how many RPMs you get. And there's a lot of shit that you would have to control if you wanted to do that directly. You'd have to control, the throttle and, the fuel injectors and the valves and a whole bunch of other shit. And I mean, it's not impossible. You could learn how to control all those things and you could pull all the levers, maybe on a simple engine anyways, and you could control the engine like that. But it's not an easy way to control an engine. And the main problem with that is, let's say you learn how to control an engine like that and you're all good at it, and then somebody changes the engine. It's a whole different kind of engine. Now it's a diesel engine. All the levers, all the things, it's working on a different principle, and you're fucked. Everything you learned is all out the window. Now contrast that with a simple interface a gas pedal. All right. So you've got a gas pedal and you push the gas pedal, and then some kind of internal implementation translates that into all of the controls that are needed to control the engine. And so you, as the user of the engine, now all you need to do is you need to know how to push the pedal, and how much of a pedal depression gives you how much power. And once you've learned that, you can switch out different kinds of engines, and as long as you also fix the interface between the pedal and the engine, the user will not have to learn anything new. They will be able to control any kind of engine as long as you specify a pedal interface for it. And that's one of the main powers of encapsulation. You can change the internal guts of a system, and you won't break everyone who depends on that system. Other advantages are, of course, it's easier to understand an object if you hide all of the nasty internals and you only present some very simple interfaces. Again, with the engine, it would be really fucking hard to learn to drive a car if you had to first learn the principles behind an internal combustion engine and how they work and how to manually operate all of the little controls on them. But it's really freaking simple to understand with just a pedal. So by doing this, you make a simpler interface to the object. You reduce the amount of complexity that's exposed to the system as a whole. You keep the complexity packaged up into the objects, into the classes, and you just have simple interfaces, and that reduces the complexity of the whole system, and that makes it easier to maintain, easier to extend, and less likely to just, completely shit the bed. Another principle is, the idea of security. And I'm not talking about the security like a hacker trying to, break something. Encapsulation is going to help you with that. But let me ask you a question. You're going to lend somebody $5. Do you lend them $5 by giving you your whole wallet and hoping that they're going to take out $5 and give the rest back to you? Or do you take out $5 yourself and only give them that, maintaining control of your wallet? That's the idea behind encapsulation security. It's to prevent basically well-meaning people from corrupting your shit. It's the principle of least trust. Don't trust anyone not to fuck everything up. And, you might say, well, I'm not going to code in a team. I'm just going to be by myself, so I don't have anyone that I don't have to trust. Wrong. The number one important person to protect your code from is yourself. Now, programming noobs like to ignore these features like data hiding and, const correctness. And they just say, well, that's fine, but I'm only coding by myself and I can trust me, right? No, you fucking can't. When you become an experienced programmer, you will finally learn that, holy shit, I fuck shit up all the time. I better make my code tight to protect it from me. Now, it can be easier to, instead of creating proper member functions and using data hiding, to, give in to the dark side and just let objects touch each other on the privates all the time.
Once you start down the dark path, forever will it dominate your destiny, consume you it will.
Is the dark side stronger?
No. Quicker, busier, more seductive.
But if you can learn to exercise a little bit of, self-restraint, a little bit of discipline, you're going to have a lot more success, especially when you're trying to create larger systems of code. But also keep one thing in mind, and that is that it's possible to go too far in the opposite direction, to try to, encapsulate everything and never break encapsulation and never give anything, not 1 inch, always make everything private, nobody gets access to anything, lock that shit down, and you end up with something that's so goddamn hard to work with that it's motherfucking gridlock up in this bitch. So you got to maintain a level head. You got to keep a balance. And where that balance lies, you learn that through experience and through, reading a lot of other people's code and getting an idea of what's normal and what works and what you like. And, I'm going to try to give you examples of a good level of encapsulation and code tightness. But, keep an open mind and don't be afraid to experiment on your own. I'm going to put some links on the wiki, maybe some more information on encapsulation and its philosophy. But also let me know in the comments if you have any good links on this topic. And if I like them, I might add them to the wiki page and then everyone can refer to them. So in summary, just expose the minimum needed for the outside world. Don't make getters and setters for everything. And when you're exposing internals, getters are, more palatable than setters, and get and set is better than raw exposing of member data. But before you resort to, getters and setters, try doing whole operations inside of member functions so that you don't need to do get and set. What I mean by that is, instead of calculating the position of the poo by getting the velocity and getting the position, adding them together, and then setting, why don't you just do that whole calculation inside of the poo object? That way you keep all that detail internal and bound up inside of the class. And lastly, don't go full retard on the encapsulation. Sometimes you gotta expose things, especially getting functions. I write getters all the time. And just go with the flow. Do what works best. Haters gonna hate and all that. Alright, now it's time for the homework, and I guess you could probably see this one coming, but we encapsulated the fuck out of the poo class. Now I want you to encapsulate the dude class. Make it all sweet and tight for me, girl. And I'm going to give you my take on how to do that in the next video. I also want you to do one more thing, and that is to increase the number of poo from 3 to 9. But until then, this was my take on encapsulation. I hope you enjoyed it. Thanks for watching, and a super big ups to my Patreon peeps, and I'll see you guys soon with some more C++.